Okay, hello. I'm going to start off with the very first question about science misconceptions. So, a misconception is just a false belief that someone has, and they just think something about it is different than what it actually is. And so, two common misconceptions are the sun is closer during the summer and farther during the winter, and then another one is that the phases of the moon are caused by Earth's shadows. And then in the classroom, to help students figure out these misconceptions, I plan to just be able to allow them to fail and then to figure it out on their own and just explore their beliefs and figure out what the right answer is. So, the progression of standards, the second question. So, a progression of standards is, which I have my phone right here, that's why I'm looking this way. But it is just a way to see what the students should learn in each grade. So it'll tell you say third grade will tell you like in second grade what they should know, so that going into third grade then you know what you need to teach them and what the students are already coming in with, and then it shows you in fourth grade what they should know, so it just progressively adds on and builds onto each other. So the progression from K to 12, it's focusing on the roles of water. So in K through 2, students just focus on the fact that you can find water in many forms and in many places around the world. And then in grades 3 to 5, they learn that water is found in oceans and fresh waters and places like that. And then in grades 6 through 8, they learn about the water cycle and then the atmosphere and then the effects that it can have and what it does. And then in grades 9 through 12, the students will learn about the water's chemical and physical properties and then how the earth is affected by them. So pretty much the standard is just understanding the structure of the matter, and they will start building on this knowledge in second grade, and then they wait, hold on. Yeah, so the standard, sorry, it's been a long day. They will, the standard that you gave us, like acting like we were in a fifth grade teacher, so in second grade they'll start learning about the object made of small pieces and it can be disassembled and reassembled in a new object. And then when they're in fifth grade, I as the teacher will help them to find different properties of various materials through investigation and experimenting. And then this will help them so that in middle school they will be able to learn about the natural resources and how they undergo chemical processes to transform into other uses that we can use. So that's what I will do. So now the 5E learning cycle. So to start off with, you start with the engage, and that's pretty much just hooking the students. And so an example of hooking them would be to read a story to them and discuss it, have them watch a video that would intrigue them but not give them the full answers about what you're getting ready to teach them so that they can learn. Then the explore part is the students investigating themselves to figure out why things work the way that they do. You want to give them a chance to fail and make mistakes, and not only make the mistakes but learn from them. And so like an example of that would be you could have them build a structure and then use wind or water to try to destroy it and see how well it can withstand it. And you can give them limited materials too, so that they have to have deeper thinking to figure out, oh, well, if I do this, this works better, and if I don't use this, and it won't work. And but giving them limited resources helps. The explain part, pretty much you want the students to be able to explain what they just did and why it works and why it doesn't work and understand the whole gist of it. So something that's super easy is you could just use a graphic organizer so that the students could just map out their thinking. And you could even give that to them during the explore part so that they have written down exactly what they did. And then the elaborate, they build on this knowledge and then they apply the knowledge in a new way. So like something super easy that we always did was just having the students create a video with certain guidelines. So the evaluate is a way for the teacher to gauge whether the students understand it or not. So that was when the teacher would want to build a rubric to be able to grade those videos so that, one, the students not only know what they need to do, and two, the teacher can make sure that they hit on every point that they were supposed to, so that the teacher can know whether or not they fully understood the content. So next question's about the engineering design process. So the stages of it are ask, imagine, plan, create, and improve. And so first off, the students will ask what the problem is that they're trying to solve, figure that out, basics. Then they'll brainstorm some solutions. Then they'll figure out what materials they need to be able to accomplish this task. And then they will create this design that they have planned out. Then they might fail at it. Hopefully they fail so then they can learn from it. And then they will start the process all over again and figure out what to do better and to make sure that it works. So I think that deep thinking happens in the improve stage because it's the only one that really makes sense, I feel like, because they have to sit there and think, well, this didn't work because of this, and what would work better. And so I just feel like it takes more, thought and time to figure that out. So yeah, I would say the improve stage. And then the last thing was the feedback. So as much as I complain about having to do the 3 lesson plans, I think at the end, it taught me so much, because when we did our own group lesson plan, I was like, oh, this is easy. But it was easy because I had 3 people doing it, and it made so much sense. But then when I had to do 3 on my own, and I had to sit down and think, well, that wouldn't be as strong of an idea as this would. I could do this, or what about this? It really put me in that teacher mindset, what is going to be the most beneficial for my students. And so it was just cool to, really think about it. I don't know. I just really liked that a lot. It was a lot of work, but I think it really paid off because I feel a lot more confident going into teaching science, which I know was your whole plan. So you did a good job. And then one assignment that I wasn't really sure. It was hard to come up with a bad assignment, I'll tell you that, because I knew why we were doing every assignment in class, and I enjoyed it because there was always a purpose. So this was really hard. But the one that I would say was probably just about safety rules, because to us, as adults, we already knew most of the safety rules, but I could see why that would be beneficial in a classroom. So I see why you had us do it, but it wasn't really necessary to go into that much explanation and making up a whole poster and class discussion about that. I think it could have been cut shorter a little bit. But so that is all my video, and I'm over time, but I just wanted to thank you so much for this whole semester. You are definitely one of my favorite teachers. And you know how they always say, oh, what was your favorite teacher in high school? Well, you made the list. You're my favorite teacher in college. So thank you so much. I hope you have a great semester next year. And thank you. I appreciate it.